Hi, this is Elan with my mousetrap card project. And so first, we had to figure out the energy stored in the mousetrap by using the torsion wheel, which we set at different angles. And so like 180, we got 5.233, and we put it on a line fit curve in Logger Pro, and that's the line that we got. This is a position time graph that we got from tracking the car's movement from start to finish using Tracker, which we use to find the displacement, which is 4.1 meters, and that is basically how far the car went in total time. For mass, we know that 9.8 newtons equals 1 kilogram, and our total force equals to 5.233 newtons, and so you divide our total force by 10 newtons per kilogram, and so we get 5.233 newtons divided by 10 newtons per kilogram equals 0.5233 kilograms. And our maximum velocity equals 0.622 meters per second. And so for kinetic energy, we plug that into the equation. EK equals 1/2 mv squared, and so it equals to 1/2 0.5233 kilograms times 0.622 squared, and that equals to 0.101 kilojoules. And again, displacement equals to 4.1 meters. This is a graph of the velocity that shows the car speeding up and slowing down. The lines are the slopes of the velocities of the car, which are the two different accelerations. The car's positive acceleration for when the car is at its greatest speed is 0.06875 meters per second squared. The car's negative acceleration for when it is decreasing to zero is negative 0.08406 meters per second squared. Now for the force diagram, weight and normal cancel out, so we're left with, for speeding, is our mass of 0.5233 kilograms and a 5.233 newton string pulling to the right and some friction going to the left. And for slowing down, we have the 0.5233 kilogram of mass and just friction, and there is no force because the tension from the string is gone. And for the total force, we know that E equals ma, and so for speeding up, we did energy equals to 0.5233 kilograms, which is our mass, times 0.06875 meters per second squared, which equals to 0.036 newtons. And for slowing down, we have the same mass of 0.5233 kilograms times negative 0.08406 meters per second squared, which equals to negative 0.044 newtons. For the energy flow diagram, the car begins at rest with its velocity equal to 0, and all of its energy is in the E elastic with 6 blocks, and it has 0 for E kinetic because it's not moving, and none for E gravitational either because it's not going up or down. You can take away 1 for E disc because the car loses energy because of friction. And in the second diagram, it is at its highest velocity and no longer has any E elastic anymore, since it is unraveled and the energy has now been converted into kinetic energy with 5 blocks. It still does not have any E gravitational because it doesn't move up or down. In the picture at the bottom, the car has reached its maximum velocity, so all of its energy has now been converted into kinetic energy, which is 5. And then energy dissipates due to friction, so it loses 5, and then it reaches 0 for all energy since the car has stopped moving due to the loss of all its energy.